In this topic, we're going to discuss how to solve radical equations. The definition of a radical equation is pretty straightforward. A radical equation is any equation that has a radical expression, so an nth root. Equations like square root of x equals 12 or cube root of 16 minus x plus x equals 3, these are radical equations because they have equal signs, so they're equations, and they have roots. Right? This has a square root, this has a cube root. Right? Eventually, we're going to want to solve pretty complicated radical equations, but to understand the underlying concepts, we're going to start with a very simple equation. All right, let's try to solve square root of x equals 5 by squaring both sides. Okay, the idea in this equation is we currently have the x variable trapped by a square root, right? At the end of the day, we want to end up with x equals a number, right? Then we've solved our equation. We found the x value that works. But right now, we have square root of x. Okay, so we need to somehow get rid of that square root. And if you recall, the way to get rid of a square root operation is to square. Okay, the square root operation and the squaring operations reverse each other. Okay? Hopefully this makes sense, right? Okay. So to help us solve this equation that has a square root, we're going to square both sides. So that's what we did down here. We took the equation square root of x equals 5. We squared both sides, so we put a square here and a square here. And then we simplified. When you take the square root of x and you square it, it's just going to leave you with the x underneath. And then 5 squared is 25. So by squaring both sides, we've isolated x. More than that, hopefully the answer of x equals 25 makes sense in the original equation. Right? If you take square root of x equals 5, which was our original equation, and you plug in 25 for x and take the square root, do you get 5? Yeah, the square root of 25 is 5. Okay. So by squaring both sides, we came up with x equals 25, and that answer actually makes sense, so that's the solution to our equation. It's very important to check your solutions when you're dealing with radical equations. So the main idea for this topic tries to take what we've done and generalize it so that the same strategy will work for any radical equation. All right? We've been working with square roots because those are sort of the simplest to introduce radical equations with. But in general, we'd like to be able to solve radical equations that have any root, a cube root, a fourth root, a fifth root, whatever. Okay, so for the main idea, you see it says to solve a radical equation with an nth root. Okay, so it could be any type of root. And then we have 4 steps to follow. First, we have to isolate the root, isolate the nth root. So let me show you what that means. If you had the radical equation cube root of x minus 2 equals 3, you want to try to isolate x in this equation, which means you have to get rid of the cube root. But before you can touch that cube root, you have to isolate it. You have to quarantine it. You have to make sure that the cube root is the only thing on this side of the equation. So you would add this 2 over before you did anything else. That's isolating the nth root. Right? You would change this equation into the cube root of x equals 5, right? By adding 2 to both sides to isolate the cube root. Okay, so that's always the first step. Make sure that your root is isolated. Okay, then you raise both sides to the nth power in order to get rid of the nth root. Right, so quick example, since I have it written here, raise both sides to the nth power. Well, in this equation that I have over here, if I wanted to raise both sides to the nth power, I would cube both sides, since we have a cube root. Okay, And that has the effect of getting rid of the cube root. The cube root and the cube are reverse operations. The third step is to solve the resulting equation. In this case, after we cube, we're just left with x equals 125, right? Because 5 cubed is 125. So there's not much to solve here. This is already done. But in some cases, you may have to do more work after you've gotten rid of the root. You may end up with 2x equals 125, so you have to divide. Okay, or maybe some more complicated equation that you still have to work to solve. And then finally, in the end, you want to check all your proposed solutions to make sure you don't have any extraneous answers. Before we get to the examples, I'd like to make one quick comment about step 1 from our main idea, which was isolating the radical, or isolating the nth root. Okay, you really don't want to skip this step. Okay, it should be your starting place when you're solving any radical equation ever. Okay, let me show you why it's important to isolate the radical. All right, if you take a simple equation like square root of x minus 3 equals 7, right, and you try to solve this equation by squaring immediately without isolating the root x first, look at what happens. You're going to square both sides, okay, but you're going to have to square root x minus 3. Okay? The way that you square root x minus 3 is actually by foiling. You take root x minus 3 times root x minus 3. Okay, so if you just start this equation without thinking very much and you square both sides, you'll end up here, at which point you have to FOIL. Okay, and now, after you FOIL this, you have x minus 6 root x plus 9. You have an x and a root x in your equation. You just made your life way too hard. Okay. Let's go back to the beginning and isolate the root first. Right, let's add this 3 to isolate the square root. Plus 3 plus 3. Now this same equation just became very straightforward. It now says root x equals 10. Squaring both sides of that gives you that x equals 100. Right, because the root and the square here will go away and leave you with just x, and 10 squared is 100. Okay, so always isolate the radical first before you do anything else. So just remember, make that the first thing to do on your checklist. Isolate the root, then square both sides or cube both sides, depending on the kind of root you have. All right. Let's get to the examples so we can practice this a little more.